Hello, everybody. I'm coming to you from my little home office located in Hilden, Germany, little town cuddling up right next to Düsseldorf if you want to find it on the map. And I have to confess that I am re-recording this because the recording failed during my workshop. I'm very sorry for that. I'll try to reproduce with the same energy that I had live during the workshop. What I can't replicate so well is your questions. So if you have any questions which are still open or want to get an answer again that is not part of the recording, please reach out to the Slack channel and I will try to cover that as good as I can. Having said that, let's dive right in to the workshop Best Practices in Infrastructure Platform Engineering. All right, let's go. So things we'll touch today, a rough agenda. First, we'll talk about housekeeping and do a little bit of an intro. Um, then we'll have the first hands-on part. We'll use the 5-minute IDP setup to drive today. And when we have completed that, we'll have a first break. Obviously, as I'm recording, I'm making this break very short. Yeah? Infrastructure platform engineering. Let's talk about what that is and the first set of best practices. Then we'll cover 2 more demo cases, DB as a service and observability. And then we'll see what conclusions we can draw and yeah, try to rewalk the Q&A as good as I can from memory. So here we go. Breaks, I've already said that. They are probably going to be very short. The prerequisites for the hands-on parts, if you want to follow along, are actually in the Slack channel as well. So if you join the Slack and go into the channel, you will see them there. Or you can just follow the link up here, which points you through the 5-minute IDP tutorial. I will be using exactly this tutorial. And I'm just going to copy paste stuff over there. So you can do that as well. So let's get on the same page first. Who are we and why do we do this? So who we are Humanitec, and we serve platform engineers with a build and blend approach. What does that mean? Usually when you're talking about an internal developer platform, as it is internal to your company and it's covering your company's requirements, very specifically, you need to build it. You cannot just buy it. And the build and blend approach means that your platform probably consists of many components, and you can, for each of them, choose if you want to buy them as it be best of breed component from the market, or if you want to build them. And then in the end, you blend them all together into your platform. So you integrate them and provide the glue. That's what we think is the best strategy for platform engineering of an IDP. So we offer 2 main products. One is the orchestrator. We'll be using that one extensively today. The other one is a portal front end for the orchestrator. We'll probably use that to visualize a few things because curl requests to our API really do not make a great demo experience. On top, we have a few OSS building blocks, and we'll also be using some of them today. I'll point that out. Having said that, let's skip the marketing part and dive directly in from a bird's eye perspective, the orchestrator. How does this work? Because we're using it, you should be able to understand how that comes together. So from an abstract request to a specific implementation, we usually start with a developer who needs to somehow deploy something. And what he does, apart from solving a business problem and writing a workload to solve that problem, he defines also the resource dependencies of that workload. So the things that the workload needs to be in place inside of a runtime environment to be able to work correctly. For example, a database. And we are very opinionated that there is no better way to specify those dependencies than in the SCORE workload specification. We'll see momentarily what SCORE is about. But if that is an abstract request, which does not include every information needed, you need to have a counterpart to that, which fills in the missing information. And this is the segregation of duty between the developer and the platform engineer. The platform engineer, apart from building the overall platform, provides how resources are provisioned with resource definition and criteria specifying when they apply, which is the configuration of the platform orchestrator. The robot sitting in between those two roles, making sure that the developer can work against a fully automated self-service process, and the platform engineer is able to fill in the gaps so that the developer has the least cognitive load possible. Well, and after the orchestrator has done its job, that will lead to app configs created, infra matched and created, workloads deployed, a running and working application. Let's look at the moving parts. So first of all, this is a score file. Score is a platform agnostic and environment agnostic workload specification. Let's take a look at the important parts. We are talking about a product service here, and there are some resources being requested from the underlying platform. In this case, we want to have a Postgres DB named DB, an S3 bucket named bucket, and a DNS record, because who likes typing IP addresses? Creative naming on those resources. So there are two things which you're probably not directly observing, but which are really important when looking at score file. The first thing is it is platform agnostic. You will not see anything platform specific in here. And the reason for that is that score comes in two parts. One is the application, the specification, sorry, you're seeing here, which describes what the developer wants. And the other side is the score implementation, which takes that abstract request and translates it into the language that the platform that we want to target understands. So there are different score implementations which help to reuse the same score file towards different platforms. Also, Score is completely open source, so you can build an implementation for your specific platform if you should decide to use one where no implementation is yet available. And also, you don't see anything here which is environment specific. So Score is environment agnostic. This Score file is equally useful on top of your local machine, your dev, your staging, your production environment. So developers do not need to reason about how that Postgres database looks like. That's the answer that the platform has to figure out. Developer just says, give me one, and platform responds with the right Postgres database in regards to the context of the environment we're going towards. So let's see how that works. And I have an example for a Redis database in this case, which is here a resource definition. So once again, a simple YAML file, which helps to keep everything as code. So let's look at the important parts here. We're talking about an entity of type Redis, so Redis database or a Redis cache. This time we're using the Terraform driver. So we somehow need to specify where the Terraform module is living that is being used to create this Redis cache. And it is living here under version control in Git. Also, you can pinpoint a very specific revision and then decide when this should apply. And in this case, the deciding criterion is that the environment type is staging. So if you're going to a development environment, this will not apply. If we're going to a staging environment, this will apply. Let's see how this clicks together in reality. So Platform Orchestrator sitting there waiting to create a resource graph. We have a set of resource definitions that the platform engineering team has supplied before. So we're looking at a lot of things for staging and one for production. Postgres is highlighted in blue. And the reason for that is the developer comes around with an abstract request which contains a Postgres database. And now this is passed on via CI to the orchestrator. And usually the pipeline already knows what the context is. developer commits something to version control, well, this should go to the development environment. Somebody put a tag marking a point in code as the next release candidate, well, this point in code should probably be promoted to the staging environment. That's what's happening here. CI is passing that context onto the orchestrator, and the orchestrator can now pick the right way to create those resources the developer asked for in regards to the context staging. And in this case, the Postgres is being resolved like that. But if I look at all of the resources this workload wants to have, then this leads to the fact of this graph being created. Why is it important to have a graph in this case? Well, if you look at how a graph works, and this is a directed acyclic dependency graph in this case, then we know how to work or how to walk the graph without the need to revisit a node again, because the dependencies are clearly modeled. We know where to start and where to stop and resolve all of the dependencies in between so that we do not need to revisit a node. This is the first benefit. And the second benefit is that if you take a look at one run, which creates a graph, and the next one, which creates a graph, then the graph allows for easy detection of changes and the opportunity to revisit only the places in the graph which are actually affected by those changes. Yeah? And this is what happens here. We did look at the resource definition for Redis in the last example. Well, let's say developer wants to add one. So a cache of type Redis being added here. This leads to the fact we go through CI again. Orchestrator evaluates how should I fulfill this abstract class asked by the developer, picks out for context staging of type Redis this resource definition, which specifies that ElastiCache is being used to fulfill it. And that leads to the fact that inside of the graph, there is a new node populated. But we do not need to revisit any of the other nodes because the Redis cache does not affect them. So great, having that as a mental model of what the orchestrator is doing in the background, we can actually dive into the action and the first hands-on part. So let's look at the architecture of the 5-minute IDP setup and get it going. So 5-minute IDP architecture in less than 5 minutes. It starts with your own machine down here and the cloud up here. Why? Well, because you're running a Docker daemon, hopefully here, which is running a VM if you start a 5-minute IDP. And up here is the Humanitec orchestrator running in SaaS mode. 5-minute IDP means starting your private kind cluster as part of this setup and then asking the orchestrator to supply or to deploy something on top of your kind cluster. Well, that's going to be problematic because usually between the cloud and your machine, there is a few blocks in the middle, yeah, which totally makes sense, but is not helping. So what the 5-minute IDP offers is an agent which allows us to bypass all of the networking problems between the two and actually get the deployment going. That's how it comes together, and that's what we'll do now. So hands-on part. Once again, here's the link to the setup, or you can just follow the 5-minute IDP link here on TinyUL. Unfurled, this is this link up here. Feel free to follow what works best for you. I will literally jump over here and just go to the 5-minute IDP. Oh, I only have the local ones in my, yeah, here we go. That worked. Let's put that one over here because I want to have this here and I want to have my presentation like this. Okay, so this is the 5-minute IDP tutorial. In the workshop, I had Johannes along, one of my favorite colleagues and the actual inventor of the 5-minute IDP. It was great to have him around. So if you like how that thing is working, give him a shout out on Platform Engineering Slack. He's also there and definitely should get some positive remarks for creating that awesome thing. So here are the prerequisites. If you need to fulfill them, then you can do that as well. I already have them fulfilled, so I can start by exporting the Humanitec org. And I have a little trick up my sleeve. By changing into my 5-minute directory, I'm using a tool called the-env, which is pre-populating all of those variables. So I don't need to do this step, but you have to do it. Which means now that the environment is pre-populated, I can simply copy this part here and paste it into my terminal and let it fly. Oh, and that means you need to have a Docker daemon running. Without a Docker daemon running, you can't actually execute Docker containers, right? So as my Docker daemon was not even running, this is really live. There are no hidden caveats here. I'm doing this even though I'm re-recording live for you guys. So downloaded new image and running it for this one. If you're interested, that's the image. You can inspect it. It's royalty free. It's open source. Okay, now that this is running, I just follow the tutorial and run the installation. And the installation will first of all create a kind cluster and then continue to set up everything that is needed inside of that cluster. So the agent, for example, and it will also provide some configuration to the orchestrator's tenant that I'm using so that this comes together. Speaking of the orchestrator's tenant, here is the ask for export Humanitec org my org ID. And during the workshop, we had some asks on how to find that organization ID. There is a few options here. If you look at your URL, when you point your browser to app.humanitec.io, which is the orchestrator's UI or the portal, then behind orgs, you will find your org ID. You could also down here click on account and then see a list of your accounts, which includes the org with name and ID. I'm not going to do that because I have a horribly long list of organizations. All right, let me split that. So whenever we are working, you see left-hand side, 5-minute IDP, right-hand side, my local machine. And I am using humctl to actually get the orgs that I'm part of. And because I am part of so many, I'm going to grab for the one that's interesting. And I get the output right-hand side name, left-hand side ID. The reason why I'm showing you this is I don't know if I was clever or just lazy when setting this up. Because I don't have any capital letters in here. I don't have any spaces or strange characters, which would all be possible in the name, but not in the ID. So please get your ID. It's the one without any uppercase letters, no special symbols in there. Spaces will be replaced by hyphens. And that's the reason why you need to be careful, not take the name, but the ID, or it won't work as expected. So if you see any 403 errors, that's the reason. In the meantime, that step has completed, so I can confidently now go here and deploy a demo workload. And what is happening now is that actually humctl score deploy is being executed against the score file, which is lying around. And you can see HTTP error. Why is that the case? Let's take a look at the portal here. Reload this so I can see, oh, now I have a 5-minute IDP application. And currently the workload is not healthy. So the deployment was successful and is reported as running due to that. But Kubernetes in the background is catching up, pulling in the image, and actually starting the pod. That's the reason why this is unhealthy. Look, now it changed to healthy. And the next one did bring me back the URL where that thing is running. Means I can actually open it up and see application is there and talking to a Postgres database. Great. Let's take a look at how that come together. So first of all, I'm quickly going to cat the score file so you can see what we've deployed. Yeah. So this is the sample score app project. Here we are binding the resource properties or the resources properties to the variables, which will be passed on to the environment of the application at runtime. And we are asking for a DB of type Postgres down here. So that is the reason why we're getting a DB of type Postgres. But the question is, where's that coming from, right? Let's take a look at the workload, take a look at the database, which is resource dependency. And it says there is a resource definition, which is fulfilling this. Let's take a look at that one. Go to resource management, filtering for Postgres. And because this is my demo subscription, you will probably see a few options here, which you might not have in your own subscription. But the relevant one is the 5-minute IDP one, which is, as you can see, hello world, externals DB. This is the one which is being used. The matching criteria say if the application ID is 5-minute IDP and then 4 random letters, so yours will change most probably, then use this one. And the configuration, it's using the so-called template driver, which writes out Kubernetes manifests to the deployment stream, is actually running a stateful set that is running just a container, a Postgres container. Yeah? Okay, so this is possible, but most probably as far from infrastructure platform engineering as it gets. Nevertheless, 5-minute IDP up and running. That's great. Let's carry on. So break, 5 minutes over. Infrastructure platform engineering. Let's talk about first what that means and why I'm saying what we just did is as far away from infrastructure platform engineering as it gets. So when I started to think about infrastructure platform engineering, I had some ideas of what that could be. And I've brought to you my first 2 scribbles that came to my mind. So first one is building a platform that helps to lifecycle infrastructure. And to a certain degree, that is very true. This is what infrastructure platform engineering can do. But the interesting part literally is when infrastructure platform engineers think about ways how not to only do things better for themselves, but how to make their services, because infrastructure and operations teams are usually about service providing, providing something like a database as a service in your company, how to expose that better and integrate that better into the outside world. And that was my second idea, building the integrations for that platform into an internal developer platform from the technical, but also from the processual and from the people perspective. So how does that pan out? Let's take a look. Let's try to take an unconventional approach. Let's imagine this as a silo, because silos are awesome. And if you don't trust me in saying this, if you possibly can remember the intro session of PlatformCon, where Kelsey Hightower talked to Caspar, then they were having this airport analogy. And Kelsey was saying, if you want to fly somewhere, what you literally don't want to have is that you go to the airport, then check in your own baggage, carry that baggage to the plane, put it in the hold yourself, enter the plane, sit down on the pilot seat, fly the plane to the destination, get your baggage out of the hold again, exit the plane, exit the airport, and then carry on with wherever you wanted to go. What you rather would most probably like to have is you go to the airport, you drop off your baggage, you enter the plane, you get flown to your destination, exit the plane, your baggage is already waiting for you, you pick it up and go on your way. And the reason for that is that there is a silo which is covering all of the aspects of air travel, but it has a very clearly defined interface with a contract. And that translates into silos are awesome. The deciding criterion for what if they are or not is if they have a clear API in place. If you want to have a little bit more context around that, we're doing this all over the place in software engineering, right? Domain-driven design. The core deciding element is a bounded context. Team topologies. How to design team borders and communication schemes. And obviously, infra and platform engineering. Let's take a closer look at that one. So, what does it mean for infrastructure platform engineering? If you take the second approach, it is about taking your as a service or your infrastructure platform and defining a clear interface, defining clear contracts, which allow for the fact that it can be better embedded into the software development lifecycle, the part that an internal developer platform cares about. So to give you a very concrete example, DB as a service has so many day two tasks, it makes no sense to integrate this into any other construct because not only those are the bespoke tasks, but also the people who carry them out are bespoke specialists, seasoned database administrators who care for the health and all of the other properties of the database instances, which are run behind the DB as a service facade. Yeah. You probably want to expose that in a better way, but you probably don't want to integrate those database admins into a different contract or concept because what they do in their silo is exactly the right thing. And what you want to happen is you want to have that clear interface so they can carry out their job in freedom. And also the people who are working against that interface have the freedom to carry out their job without any deeper knowledge of what's happening inside of the silo. All right. And what does that mean? This is almost the definition of platform engineering, right? Provide an abstraction that makes access to the underlying infrastructure and its capabilities as easy as possible without the need to fully understand all of the technology and traits which are used to supply that infrastructure to you. This is what platform engineering usually does. Okay, so let's see where that mental image takes us. So what is the right API when trying to follow this best practice? Well, it is ubiquitous. You should aim for the same API on the front end for all users and all services. It should be interface agnostic. Users have workflows. Try not to interrupt them. API, CLI, UI, they are all equally important. And the hyperscalers show us that this is the case. This is one of their success recipes. Yeah. And be prepared for complex backend logic. Binding your backend into the uniform front end shouldn't be hard. So there has to be an interface in between, which is prepared to care for the fact that probably your as a service is life cycled in a very specific way. Yeah. And while the contract in the front end needs to be simple and abstract, somebody needs to translate into what needs to happen in the background. So what is the secret sauce? Interfaces. It's clear that we need them. They are a necessity, but they are not the deciding criterion. Solving problems. It's great to do that. Users can now have reduced cognitive load and concentrate on doing their job instead of being shift lefted into trouble. But that's not the deciding factor as well. The deciding factor, if you observe, once again, the business model of hyperscalers and the reason why they are so popular with developers and architects is composability. So building software means composing something from commodity building blocks and only adding the needed rest. You can observe that in software building every day. Developers, what do they look for? They look for frameworks, they look for libraries, they look for things that are already there and try to get them into their product as the first step, and then try to fill in the gaps. And interestingly enough, for infrastructure, that was only possible with hyperscalers. But if you follow the ways of infrastructure platform engineering, that is past tense. So this is literally the secret sauce. If you make your services be available not only in an abstracted self-service interface so that they are more easy to acquire and discover by your end customers, so to speak, but you need to be able to fit them in to a greater concept so that they are literally a composable building block. And what that means, we'll see through the following hands-on exercises. All right, let's see the problem field once again. If you look at how the different personas observe that, then on the right-hand side, we have a developer here who is missing self-service. Because of that, has high waiting times, everything's slow, right? And because he needs to understand the infrastructure that he wants, he needs to have deep knowledge of the technology and its configuration, and that leads to high cognitive load. On the other side, infrastructure and operations people are sitting on the other side of the equation with the missing self-service. Yeah, they're getting all of the ticket ops and have to play ticket robot because the configuration is created by the developers. That leads to low standardization, insecure configurations, and many reviews that need to be done. Cost is spiraling out of control in this model. So how to attack that problem? On the developer experience platform engineering side, you mostly see people trying to get the automation better because 100% automated means full self-service capabilities without any stops in the process. That's great to have. That's what developers want. They want to get their infrastructure and be on the way and not wait for anybody else to complete that task before they can carry on with their rapid inner loop, which usually means agile, writing code, running code, seeing if it works or breaks, next iteration. Yeah, those cycles turn really, really fast, and interrupting them by tickets is horrible for developers because it's a stop the world event for them. But on the other side of that, live the infrastructure platform engineers, and their lifeblood is standardization. Because once you've reached full automation, that means you probably get a ton of those resources. They are now so easy to get, so people do that. And if you're missing standardization, then that means the infrastructure and operations people have to deal with thousands of instances instead of, let's say, 5 templates, and each of them is carrying 200 instances in the background. But if you have that template that you can pick and modify, then obviously that gives you a central point where you can modify and then roll out changes to the instances. And if you do it like this, that leads to the fact that time to market and cost goes down and innovation goes up, and managers can feel happy being impaled on top of this interesting pyramid. So let's see how that pans out. How should a team look like that lives inside of such a construct? Oops. So first of all, If you're providing something as a service right now, you probably have that down. Don't stop doing that, right? You probably have the right team already. If you have someone who is dabbling in the art of interface design already and is specializing into that, all the better. If you don't have someone like this right now, you probably will need one who is versed in these skills, because that's what infrastructure platform engineering is about, right? Embedding your as a service into a broader world. So infrastructure platform, if you're building one, and you should only do that if you really need to, then mimic the IDP model. There are tons of resources and talks this PlatformCon on what that means, configuring a team for an IDP journey. Please refer to there. Yeah? What I can say is, what is the best practice there is to focus on the inside scope, the automation and the standardization of your infrastructure platform. And then take the last step when it comes to the IDP, because that is the overarching construct which wraps all of those as a service offerings into the software development lifecycle. Yeah? Send your API or interface responsibles into the platform team of the IDP. Having a seat at the table there ensures that you're connected and aligned with the SDLC in the best way possible. Okay, so let's do a first demo case. DB as a service. I can't build a full DB as a service offering with you in just a few minutes, yeah. But I can try to get close. Let's see how close I can get. And how are we going to do this? So remember, that's what we have as the grounding technology, which is putting something on your 5-minute IDP. And now, if we want to have something as a service, we're going to use Cloud Native PG. That is an operator which can be installed on top of your 5-minute IDP cluster, which means it is sitting there and playing prop DB as a service. Why? Because I have a clearly defined interface. I need to just put out a Kubernetes manifest, and then that operator will actually create a database for me. But this time, it's not something that is just written out by our template driver. It is really an as a service offering, because the operator cares for the whole life cycling, the management, and the ton of things for those instances. And how do we make that happen? Well, we just need to figure out how to provide the right resource definition, which wraps the request to Cloud Native PG into a format that is self-service auditable by the developer. So let's replace our hacky, wacky local cluster DB as a service implementation with a real one. All right, off to the races. So first thing I need to do is I'm going to start a VS instance here. And as you can see, I have prepared a few things. Do not let that stop you. I'm literally, once again, using tutorials and copy pasting, but not for Cloud Native PG. Why is that the case? Because literally that here is the installation of the Cloud Native PG operator. One of the reasons I have picked it, you could have picked any kind of operator to play prop as a service, but I picked this one because it is so easy to get it. Okay, so left-hand side means I'm in the 5-minute IDP terminal. I'm going to put that here and apply that to my Kubernetes cluster. Okay, so that is coming up slowly but surely. Let's take a look at the entities which are actually responsible for getting myself a Postgres cluster. First of all, there is a Postgres cluster, obviously, and I'm using the PostgreSQL CMPG.io API to order myself a cluster. It has a name. one instance, right? We're playing prop here. 100 megabytes of storage should be plenty. It contains a database, has an owner or user, and that user needs to have a secret. So let's take a quick look at the secret. And the secret is actually looking like this. It needs to be a basic auth secret. That's the specification. What CNPG would like to work with. And we need to have a username and password in here. If you should decide to create such a secret manually, please observe that these two values here need to be base 64 encoded, or Kubernetes will deny your secret, and it will lead to interesting errors. Okay, so let's look at how we could possibly create a resource definition out of this. And let's take a look at the current resource definition for that, and then we go from there. Okay, so right-hand side means I'm on top of my local machine, and I can use humctl, and I literally do have a shorthand for that, which is just h. Yeah, you can create your own by just saying alias h equals humctl, and there you go. Then you can just use that fast. So humctl get resource definitions. And that gives me a few resource definitions, all of them which are available on top of inside of my organization at the moment. And the one I am actually interested in is the 5-minute IDP Postgres definition. So I want to get that one. I want the output format to be YAML, and I'm going to put that into my new pg.yaml. Okay, having done that, let's take a look at what I have. This is the resource definition, which is hell of long because it is actually creating not just a container, but also a deployment, a service, and a ton of things. So we can probably tone that down quite a bit because there's a lot in here which we don't need. App ID sounds good to me. Class is default. We can keep that. The ID can go. So secret refs, we don't need that. Driver inputs are what we are passing to the driver, which is the logic that actually lifecycles the resource. We are using the template driver here as well, because that allows us to write out custom resource. And that's going to be the cluster custom resource that Cloud Native PG actually awaits. Then we can see that happen. Obviously, if you are providing your own as a service, there might be different ways how you have shaped your interface. If you're providing your interface in form of custom resource definitions and with an operator, then you can reuse this pattern immediately. If you're providing your interface in form of a Terraform provider, for example, well, then just use the Terraform driver and create a resource definition that executes your Terraform in the right way, so you get an instance of the service without needing to dump the complexity of configuring that onto the developer. And if you have a different interface still, feel free to hit me up on Slack, and I am game to talk about the right way on how to implement the connection. Wait, we can skip the cookie part. We don't need that. But what we need is we need a username, and I'm going to make that Scott. And we need a password. I'm going to make that Tiger, because I want that to be simple. If we need to debug anything, I don't want to extract a randomly generated password. So, but what I think is a great idea is to have a database name and a Postgres name, which is coming from something different than just a fixed name. Because if I'm creating a cluster or a database coming from two different services or two databases for the same service, they should be distinct, right? And so I'm using some random generation logic to do that for me here, yeah, which is great. That's already in place. I can reuse that. Let's take a look at that. So what we're going to do is we're going to create a Postgres YAML, which is our Postgres. It's going to be located in the namespace, and then comes the manifest. I don't need all of the stuff in here because that is literally the stuff that I want to replace. And then there is also a secret YAML, and that one is looking rather good. I can take that from the name here. Just the type needs to be basic auth. And to comply to the basic auth scheme, this needs to be password. And I need to provide a username, and that can come from init user as well. So in the init part, we're initializing variables, and then down here, we can use them consistently, which also means in the output part, we need to output the host, the port, and the name of the database. That's great, but we also need to output some secrets. And those are the username and the password. And they need to be secrets, because if I put them in outputs, well, the orchestrator will correctly assume that I did just spill my information, and it won't allow me. So driver type is template. The name is great because we want to replace the existing one. I can get rid of the org ID and of the status. So having done all that, I'm still lacking my cluster. Let's take a look at this here again. Just copy that and put it in here. So this is still YAML, which means I need to be careful about indentation. So, okay, let's take all of that and move it to the right place. Now this looks like YAML. And now I just need to replace the things which need to be replaced. Okay, so first of all, this is init name. Then the database obviously needs to be init database. The owner needs to be init user. And the secret, we have given it the name init name, well, needs to be init name. And to be much more clear about, we could actually call it secret. I do like that. So I'm going to copy that down here. So those two match, and they are, that's the reason why they line up nicely. Don't need the empty line here. And that actually looks good. Don't need the empty line here either. Save that. And now we have created a resource definition that wraps our DB as a service offering into something that the orchestrator can take on as configuration. Now that I've created this resource definition, which wraps the configuration on how to create an instance of our new Postgres DB as a service offering, I can convey that to the orchestrator and replace my hacky-wacky container implementation with an actual instance coming from my as a service offering. Let's do that. I'm using humctl apply-f, my new PG YAML. And that's why I say right-hand side, humctl. This is where I convey things to the orchestrator. Left-hand side, kubectl. This is where I execute commands against Kubernetes. Okay, so left-hand side, one demo. I'm going to execute that shell script again because that's going to simply execute the deployment pipeline once again, so to speak. Yeah, execute humctl score deploy with my score file, and that's going to ask for a new instance of the database because I changed the definition of how that instance is supplied in the background. Let's wait for a few retries and see if it works. And here we go. My workload is available, and that means I can open it up again. And here we go. I have a database. So now I want to show you one more thing. And this is that it is really easy to also enable my service offering, in this case, to offer telemetry data. And for that, because I'm using Cloud Native PG, I only need to do one thing. I need to add 2 lines of code, which is monitoring enabled true. And I don't need to do all this. And enabled true seems to be a little bit. Let me check my script. I have that prepared here. Monitoring enable pod monitor true. That was the thing. So sorry for not being able to remember that. It's always good to have a plan B, right? So enable pod monitor true. Let's change that. Now the only thing I need to do is apply my resource definition again. And over here, actually also execute the pipeline once again, which is going to give me a fresh deployment, which is going to apply the new standard, how a Postgres database is configured, that I order from my DB as a service offering. And as you see, this is really fast because now, obviously, I'm just changing a little bit of configuration. Okay, so hopefully pod monitoring was enabled, and that allows me to actually go to the from installation here, because Prometheus community, there is the Kube Prometheus stack. There is installation, there is a part of the Cloud Native PG tutorial, which allows me to actually see how this is being done. Okay, cool. So I can now go here and actually install that. Okay. Once Helm has finished with that, and I can get here from this URL the dashboard, which is also provided by the project. Thankfully, because I'm literally really bad in dashboard design. I can copy that. And I can go over. Oh, wait, one more step. Obviously, I need to get the kube config. Why? Because I want to access this from my local host. So I absolutely need to do this port forward from the Community Grafana service to my local host. And I might have done this already. Look, this is already running in the background. So port 3000 is up and running. Great, which allows me to go to localhost, not 8080, but 3000, and have a look at Grafana. Let's take a look at the dashboards. Let's do a new one. Import the dashboard, put the dashboard, whoops, the dashboard code, I wanted to say. So copy the raw file here, put the dashboard code in here. Let's call it my new DB. We're going to load this. We're going to use this here. My new dashboard. Change the UID. My new dashboard. Import. And here we go. Out of nowhere, I have complete dashboard that allows me to observe my stuff. In this case here, my cluster is up. I'm not getting a lot of data, and the reason for that is I've not done a lot of resources yet that Prometheus would be able to ingest. Okay, see, I've created some traffic. So probably this is going to, yeah, let's do some more traffic. Okay, let's see if that actually refreshes. Last 7 days, let's focus on the last 5 minutes. You can see there is no replication. I can see there's CPU usage coming in, memory cache, session states, not too many, but there are a few transactions happening. That's the traffic I just generated. So I have really good visibility of what's happening out of the box as well. But obviously only for my database. But I could offer that view to the consumers of my service as well. That would be really cheap and easy. All right, so where does that take us? That takes us to the next step, the demo case observability. But let's take a look first at the main contrast, right? The demo that we just did was, okay, how do I actually take a DBS service that I've created and wrap that into a nice uniform service interface so it is self-servable, it is easily discoverable, it is easily usable by the end customers, the developers. And I've done that using the mechanisms of the orchestrator, which is providing the wrapping IDP around my platform engineering endeavor. But let's take a look at observability. This is different. This is not an as a service. This is a cross-cutting concern, which probably spans a lot of as a services and also spans my applications. So let's take a look on how we are going to make this one happen. Hands-on part once again. So what now? Take a quick look at what we're going to do. Same pattern here. This time we're going to use OpenObserve because it is so easily installed. Once again, obviously in your own adventure, you can take any kind of observability that you need or want. And the only question is, wait a moment. Is it like last time? Do I just need to provide a resource definition? No, obviously not, because we don't want to order a resource which is called observability. We probably want to provide that service, but that is living outside of the scope of what we are developing. And the question is, how do we provide that service in the most convenient way to the developer then? Let's find out. So first of all, I need to get my observability tooling going. And I have prepared that. You can take a look. Once again, this is a self-hosted installation. I go to Kubernetes manifest. Those are the 3 things I need to do. Well, I actually have prepared that already. So I can literally just go ahead and do it like this. Once again, left-hand side, we are executing kubectl commands. Okay, cool. OpenObserve created. I need to get a new port forward going so I can access this from my local machine. So I'm just going to start another port forward in the background and let that thing fly. This time on port 5080. Wait, so that means I can now open connection to 5080, and that will take me to OpenObserve. The username for that is root@example.com, and the password is complex pass hash 123. Don't ask me who invented that. That's just the way it is. If you would need to find that out, it is part of the configuration of the Kubernetes objects. All right, let's see. No data ingested. Find how to ingest logs. So if I go here to the left-hand side to ingestion, I get for Kubernetes some clear instructions on how to make that happen. Great. I've prepared that one as well. So I can simply go ahead and do all of that in one step. Why do I need to, or can I do it like this? Well, because all of that stuff is actually not depending on anything. I can just let that fly. Yeah? Failed calling webhook. Oh, okay, cool. So I should have probably executed the first kubectl apply and then wait a moment. but that's not a problem. We can execute the rest a little bit later again. And what we need to do in the meantime is anyway, we need to take this part. You can't copy paste that from anywhere because this is now here prepped with hashes, which are coming from your installation. So I need to copy this. I need to modify this. And the reason for that is that if you run open observe in a normal installation, this will be a Helm chart. And the Helm chart is going to be called O2. And then there's going to be a router and a few services supplied here. But we are running the quick run one-off. So we need to get rid of that. And we need to get rid of the dash router because we only have the main executable running, which is not bad because it's giving us all that we need. We just need to adapt. All right. Oops. Copy that. Now, first of all, I need to rerun this part here. Configured. That sounds great. Now I can take my modified installation instructions, which is targeting the right part because that will install the collector. That's what you get when you are too fast. Let's see if I can just kubectl delete. Yeah. I can just delete this. Then apply it. To be sure I made no typos in between. When I did that, I'm going to quickly copy and paste that again. Like this. Change the two URL. Cannot reuse a name that is still in use. No problem. Helm, delete. O2C. Dash N. Collectore. Okay. Remove the release. Okay, so this time it worked as expected. And that leads me over here to the home page and to my application. I can possibly generate a little bit of traffic. Back to that. And here we go. 48 streams. We ingested data. Well, that was easy, right? If you do not, if you are a little bit less, speedy than me, you will not jump over this line. It's probably not 2 minutes. It's probably a bit faster, but if you don't ruin that part, you don't need to fix it, obviously. And now I have 70 streams. There's a lot of metrics being collected, but I want to take a look at logs. So I'm going to take the default screen and I'm going to select pod name. And I want my application to be the pod, the query. And I can see here, whoa, there's a lot of requests coming in. I can take a look at this request. And if I did a little bit more integration, I could also take a look at the traces here. Right? So that's coming in already. If I would be better at dashboard design, I could probably show you what the Grafana dashboard is showing here as well. I could show that to you in here because that thing is literally collecting the same metrics as the Prometheus instance. Yeah. So, but now I'm not just monitoring my database. I'm literally already monitoring my application. So why is that happening? And the answer is that if you look at your application here and the resource management, you will find something that is default Humanitec logging. And you can see it's being used by the application. And the answer why this is the case is because this is a catch-all. If nothing else is being used, then this is being used. And I need to take a little route over here to HAMCTL, get resource definition, default Humanitec logging -o YAML to show you typo time again. Yes. To show you the configuration because you can't see that in the UI. And the Kate's logging driver is being used. And because we are actually using the OpenObserve collector, which is directly looking at all pods and seeing if they write to standard out. So where usually Kubernetes would expect logs to be dropped, then it's going to scrape them and put them in here at my fingertips. So if I wanted to do something else, I would now just need to rework how that logging is being provided by the orchestrator. And by that, I could target, for example, Datadog. I could also say that, hey, in development, you're targeting your homegrown installation of something that is cheap, and in production, you're doing Datadog, which is a much more expensive service. Well, all of that is possible. You probably want to decide on the requirements of your users, what is really needed. So why are we doing this exercise? We're doing this exercise because now we're doing something that is widely different. We are providing a cross-cutting concern. And coming back to that idea of composability, if I have now ordered a database which is being provided, my application is running, and I've ordered an observability service, I literally get a full 360 view. Why? Because these building blocks are assembled by the platform, which is providing the right configuration to glue it together with the observability as well. And this is what I'm talking about when I say composability. This is the same level of integration you would expect and get from a cloud provider if you ordered a managed service from him and then take a look at the observability tooling that he's providing, right? And all of that is coming together because we are stitching different distinct capabilities together with the orchestrator. All right. Having said that, let's keep going. And it's literally already a wrap because we've executed demo cases. I hope you were able to follow along in the hands-on path, right? And have the same outcomes as me. So you have something that you can now play around with. a little bit more if you fancy. But what are the conclusions that we can draw? So let's get back to the image from the beginning. If you're building an infrastructure platform, you're basically doing a lot of the things already needed. The only problem from the software development lifecycle, from the SDLC perspective, is that you're probably living too much in your silo. It's probably looking like that. Your infrastructure platform is sitting there saying, hey, I have a lot of services. Please take your truck, drive up to my interface, then drive up to the right one, and I can load you up with what you needed. But sadly, that silo is standing somewhere in the desert, and who's going to drive there, right? In contrast, infrastructure platform engineering is doing it in this way. You still have a silo sitting somewhere in the desert, but it is easily connected to the consumers of the contents of the silo by this pipe system, which is the right API that makes this silo accessible. And by that, negates all the nasty effects of siloism, so to speak. Yeah. So infrastructure platform engineering is all about connecting the stuff you're doing in a friendly and automated way to the outside world. And by that, integrating it fully into the software development lifecycle, which is what the stakeholders of that thing, aka the developers, care about. In general, you could say if you've achieved this, you've achieved also parity between cloud providers, hyperscalers, and your data center. Because usually where you provide as a service is here from your own data center. You might also provide that on top of cloud provider basic resources, which might make your as a service offering cheaper than the cloud providers as a service offering, because usually they want to have a premium for that. And obviously, it is less buy-in into the cloud provider's model. And by that, if you would establish this in a different cloud provider or in your own data center, it would all be the same. So there are quite a few upsides to actually doing it like this. And the only thing that you needed to have on top of this was the clear interface, which is able to hook into the IDP sitting on top. And by that, puts you on eye level with what the hyperscalers are offering. All right. So what is the promise of infrastructure platform engineering? It is that you're getting your secret sauce, the composability, right? Compose simple building blocks into the architecture and then allow the developers to supply the code that solves the business problems on top of that architecture. Composability. And while doing that, what you actually acquired on the sideline is your self-service vending machine, which is the internal developer platform. Get hooked up to your as a service offerings, and by that, making them commodity and accessible to all people who partake in the software development lifecycle. Okay. I hope that this now is a great outcome that you want to achieve, but there always is day two. When you have built something and you think now you're done, usually day two comes around to ruin your day. So let's take a look at the best practices and what infrastructure platform engineering does for day two. It's really important. Thinking back once again, automation, it's the ultimate goal to provide full service, yeah, is giving you probably a lot of instances to worry about. The countering force to that is standardization. Yeah. And if you're relying on the construct of either your as a service offering, which obviously tries to minimize the invariance that can be created through the choices that you provide as part of the internal developer platform, or you have your infrastructure platform in between, which probably tries to do so already by the API. And still, you can moderate how the standardization is through the IDPs API, yeah, which makes only certain combinations, certain things accessible for the developers playing around with that. And that leads to the fact that maintenance is actually possible in the right way. So your day to work is not caring for 2,000 instances. You have probably 5 different ways, 5 different templates on how to bake an instance. And each of them cares for a smaller amount, which is their bucket of the instances. And because you have that template, you can modify that template and roll the changes out to all of the instances, which makes maintenance with so many instances not only possible, but also economically sensible. All right. So things we have touched today. Now you know what is a 5-minute IDP setup and how does it give you the tools to actually build the right interface to your as a service offering or your infrastructure platform, and then later integrate that into the real thing. I have shared from my perspective some best practices of what infrastructure platform engineering should rely on to be successful. And you have seen 2 widely different cases, one as a service and one cross-cutting concern, which form the secret sauce for infrastructure platform engineering, the composability. And I have demonstrated how you can get that to your own offering as well. So shrimp wrap and conclusions, that has happened just now, and I hope that was good, which leads me on to the question, what now? Finally, a platform. Well, an internal developer platform, right? So this is an internal developer platform reference architecture. And as you can see, this is one for multi-cloud. Yeah, so we have a resource plane, which is targeting Amazon Cloud. And through a gateway, we have a resource plane, which is targeting your own data center, which is providing the same stuff on top of OpenShift container platform. The question is, what is important here? Important are the so-called planes, the big gray boxes, because they give direction. And then you have the boxes inside. They are important because they describe capabilities. And you probably can do with a platform with a lot more boxes because it has more capabilities. You probably can't do with one that has a lot less boxes because this is the most common denominator that we have derived over, I don't know, hundreds, possibly thousands of platforming attempts. And we are offering those reference architectures free of charge. They are open source. They are completely terraformed. So you should be able to get one going in basically an hour of time, which is not a lot, but still too much time for a workshop like today. That's the reason why we did the 5-minute IDP. But this is the natural progression path because this then can, from the Terraform, run into your estate. Yeah, and in this case, this whole setup here is staying on Amazon, but we are targeting an on-prem data center as well. There are no specific reasons why it's configured like that. We have different implementations which target all major cloud providers, and we have a reference architecture on how to run that on top of OpenShift as well. If you have different needs, well, we can always get a discussion going and probably design a reference architecture for your specific case. Just hit me up on Slack at Jay, that's me. Let me know, and I am happy to talk about that. I'm always happy to share a virtual cup of platform coffee anyway. And that brings me to the Q and hopefully A. And I'm very sorry that I do not have all of the questions. You had some great ones. I'm just trying to remember if I can remember anything. And I would say before I try to patch something together from my leaky memory, yeah, I'd rather once again extend the invite for you to go ahead and talk to me on Slack, either in the five or in the infrastructure platform engineering webinar channel, or just shoot me a direct message. Yeah, start a conversation in general, whatever, and I will respond to your questions. And then we can possibly share that in the right way as well, so other people can take their part in the conversation. And by that, we might even get a more interesting and better answer from the community perspective than we could have in me answering right now. I hope this workshop and the re-recording was worthwhile for you. I hope you had some fun. And yeah, hope to see you soon. Have a great day and keep on building.